Okay, I said today that we would look at some trig and do some revision. So what I'm going to do is give you a few questions and then I will go over the answers with you. So question 1 says, show that tan 75 equals root 3 plus 1 over root 3 minus 1. So if you pause the video now, copy this down, have a go at it, and then turn the video back on when you think you've had a go, or if you're getting a bit stuck and you want to get a bit of a hint on this. So if I was doing this, if I want to show it and I know its exact values, the exact values I know are 45, 30 and 60, aren't they? And to get 75, I'll just be adding these together. So I know that probably what I'm going to have to do is, instead of writing it as tan 75, I'm going to have to write it as tan 30 plus 45. And the rule for tan, so if you have tan A plus B, the rule is tan A plus B equals tan A plus tan B divided by 1 minus tan A tan B. And I want some exact values. So the exact values I'm going to use, if I think about the little formulae triangle, if these are both 45, 1, 1, root 2, and then that's a 60, 30, 2, 1, root 3. So tan 45 is 1, and tan 30 is 1 over root 3. So if I look at this question now, and I put this into that formula, then tan of 30 plus 45 must be tan 30 plus tan 45 divided by 1 minus tan 30 times tan 45. And if I put the values in, tan 30 is 1 over root 3 plus tan 45 is 1 divided by 1 minus tan 30 to 1 over root 3 times tan 45, so I'm timesing that by 1. And if I then multiply everything here through by root 3, I'll get 1 plus root 3 over root 3 minus 1. And actually that's the same as the one above, except the top line, rather than 1 plus root 3, they've written root 3 plus 1 over root 3 minus 1. So I've got it in the same format. Okay, then question 2 is a prove that one. So a trig expression that you can prove. So it says prove that cos 2 theta divided by cos squared theta plus tan squared theta equals 1. So pause, have a go at this one, and again unpause if you want a bit of a hint or you want to check through your answer. Okay then, so let's have a look at what we know. So my first thought here, if I see this, obviously I'm going to start with the left hand side. There's not much I can do with the right hand side. So looking at the left hand side of this equation, the first thing I've spotted is that tan is equal to sine over cos. So tan squared must be sine squared over cos squared. And I'm thinking that's pretty good, because then I've got the same denominator in each fraction. And what I could then write is cos 2 theta plus sine squared theta over cos squared theta is that left hand side. Right, I need to now try and get this to equal 1, but I'm going to look at this cos squared theta. Now I've got some options, or cos 2 theta, sorry, not cos squared, cos 2 theta. I've got some options for this cos 2 theta. So I can write it as something like 2 cos squared theta minus 1, 1 minus 2 sine squared. I'm actually going to use this one. So I'm going to use the rule that cos 2 theta equals cos squared theta minus sine squared theta. And the reason I've picked that one, hopefully you've spotted it, but if I were to replace that cos 2 theta with cos squared theta minus sine squared theta plus sine squared theta, all over cos squared theta. In the top line, the minus sine squared theta plus sine squared theta cancel each other out. So I'm simply left with cos squared theta over cos squared theta, which equals 1, which equals your right-hand side. So I've proven that identity or that statement. Okay, third question is solve a trig equation. So can you solve cos to the power 4 theta equals 2 sine squared theta times cos squared theta? And we want our answers in degrees between 0 and 360. So pause and have a go at this one. Okay, this one's a little bit tricky. So first step I did was I said, well, I've got this in terms of cos and sine. The easiest way to deal with these is, if we could, is have it just in terms of one trig function. So the first thing I did with this was I said, let's make this sine squared into 1 minus cos squared theta times cos squared theta. And then I simply said, well, let's multiply out what I get on that side. So that will be, if you think of it as 2 cos squared theta times 1 minus cos squared theta, I'm going to get 2 cos squared theta minus 2 cos to the 4 theta. And then if I bring that cos to the 4 theta over to that side, I take 2 cos squared theta from that side, theta, I get 0 on the other side. And what I can now do, once I've got it equal to 0, I kind of want to factorise then. So I've got two different factors. So if I take out a factor of cos squared theta, I'm going to get 3 cos squared theta minus 2 in my brackets. And then I've got some different options here. So my first option for this to be true is I could either say, well, cos squared theta would have to be 0. And that would mean that cos theta would have to be 0. And hopefully you remember, even just by thinking about the graph, where between 0 and 360 is cos theta 0, it's at 90 and 270 degrees. And if we look at the other one, well, the other way that this whole answer could give me 0 would be if 3 cos squared theta minus 2 equals 0. So cos squared theta must equal 2/3. So cos theta must equal plus or minus the square root of 2/3. So if I do this in two separate bits, if we say let's make it equal to the positive root first, so I'm going to then on my calculator do inverse cos of root 2/3, and that gives me an angle of 35.26 degrees. Now I would then think about that on my cast diagram and say, well, cos is positive, so I'm going to get an angle in here and an angle in here. The calculators give me that that's 35.26, so this must be 35.26. So one angle is 35.26, the other angle is this one, because I'm going up to 360. So that one will be 360 minus 35.26, and that gives me 324.74 degrees. And then the second option here is if we were to use the cos theta equals minus root 2 over 3. And if I type that into my calculator gives me an angle of 144.74 degrees. So again, if I think about my cast diagram, where cos is negative, it's here and here. So if this one's 144.74, you can work out this one, or you could say this one's 144.74, but the other angle will be, if I go around this way, it would be 215.26 degrees. So overall, I've got 35.26 degrees, 90 degrees, 144.74 degrees, 215.26, 270, and then I've got 324.74 degrees. And those are all of my answers or solutions to this equation. Okay, last question then is, I'm going to tell you that theta is an acute angle and that cos theta equals 4/5. And the questions just show that one. And can we show that cos theta plus pi over 4 equals root 2 over 10. So again, copy that down, pause it and have a go at this question, and then you can unpause and have a look at the answer in a second. Okay then, first thing I would think about in this is, I know that this is going to be something to do with the cos A plus B formula, because it's cos theta plus pi over 4. So I know I'm going to need cos of theta, sine of theta, cos of pi over 4 and sine of pi over 4. So my first thing I'm going to do is just work out what those all are. So if theta is acute, let's imagine I've got a little triangle, theta is acute. If cos theta is 4/5, that's A over H, this other side here must be 3. So I could say straight away that sine theta must be 3/5. So cos theta is 4/5, sine theta is 3/5. And then with the pi over 4, so remember pi over 4 is 45 degrees. So if that's pi over 4, 1 root 2. So cos pi over 4 is 1 over root 2. And sine pi over 4 is also 1 over root 2. So the formula that I'm going to use is the cos of A plus B, which is equal to cos A cos B minus sine A sine B. So if I put in what I know from these equations, cos theta plus pi over 4 is equivalent to cos theta times cos pi over 4 minus sine theta times sine pi over 4. So I've got cos theta, so that's the same as 4/5, times cos pi over 4, that's the same as 1 over root 2, minus sine theta, that's 3/5, and sine pi over 4, that's the same as 1 over root 2. So I've got 4 over 5 root 2 minus 3 over 5 root 2, which is 1 over 5 root 2. Now that unfortunately doesn't look like what I've got at the top, does it? It's not quite the same. But all they've done is they've rationalised the denominator. So to rationalise the denominator of this, what I'm going to do is I'm going to times both the top and bottom by root 2. So if I times the top and bottom by root 2, 1 times root 2 is root 2. Bottom line, 5 times 5 root 2 times root 2. So it's just 5 times root 2 times root 2 is 2. 5 times 2 is 10. We've got the same as the answer above. That's all for the lesson today. If you've got some extra time, you can just go back and have a look at a few of the trig questions yourself on the mixed exercise, or have a go at some of the parametric mixed exercises ones just after the ones we've been doing. And then next week we will start some of the next chapter. So have a lovely weekend, and I will see you all on Tuesday.